3-47. This problem is based off of the problem 3-46. So if you haven't done 346 yet, you may want to go ahead and complete 3-46 before you try to do 3-47. It states, look back at the expressions in problem 3-46 that are not equivalent. Are there any values of the variables that would make them equal? Justify your reasoning. Well, we already completed 3-46 and we got that D, E, and F had equations or expressions that were not equivalent. Now they're asking us to see if there are any values that we could put in for our variables that would make these expressions actually equivalent to each other. So as we look at our first one, D, we have A plus B, the sum, squared, and then we have the sum of A squared and B squared. Well, if we look at this here, the value for A or a value for B, if we put in 0 for either one of them, we could see then that it would simplify our expression down. I'm going to put in 0 for A here in the first one. So I've got 0 plus B squared. Well, if I add 0 to anything, we know that whatever we're adding it to is just going to remain the same. So that would be like the same as saying B squared. Well, if we did the same thing over here and we put in our 0 for our A, we'd have 0 squared plus B squared would leave us with a B squared. So it's pretty safe to say here that if the value of A is 0, then it's not really going to matter what B is, because whatever B ends up being, if I square it, it's going to be the same thing as if I squared it over here. Now what you need to ask yourself here is, would this also be true if B was 0 instead of A? And in that case, it would. We would be left with an A squared if B was 0. Let's go ahead and write that. If B equaled 0, then we'd have A would equal 2. And if B equaled 0 here, we'd have A squared plus 0 squared, which would then still leave us with an A squared. So it's safe to say here on part D that there are values that for A and B that would make these two expressions equivalent. In this case, if we said if A or B equals 0, then our two expressions will be equivalent, but they'll be only in that instance. So that's for part D. For part E, we have x to the 6th power divided by x to the 2nd power, and we're comparing it to x to the 3rd power. Well, in the last problem, we went ahead and we simplified this, and we got that x to the 6th divided by x squared, we got x to the 4th power. So if you look closely at those, remember, this is like saying x times itself 4 times, and this is like saying x times itself 3 times. Well, what numbers can you multiply times itself over and over repeatedly and still end up with the same value? In this case, if x is 1, then these two expressions are going to be equivalent. Our x to the 6th over x squared will equal x to the 3rd. We'll end up with the expression 1 equals 1. Now a question for you here is, what if x equals 0? If we plug it back in here, we'd have 0 to the 6th power over 0 to the 2nd power. Well, the problem with that is we can never have 0 in our denominator. If you had 0 squared, and you had 0 to the 6th, this is going to be undefined. You can't have 0 in your denominator. So the only value that will make this statement true, or make these equivalent, would be if x equals 1. So that will be our answer for 3-47 part E. So if x equals 1, we get that they are equivalent there. The last part is part F. It says y equals 3 times the quantity of x minus 5 plus 2, and y equals 2x minus 8. We already determined that these were not equivalent. Now, both of these are linear equations, and if we want to figure out when they're going to be equivalent, we need to figure out what point these two equations are going to share. So the easiest way to do that then would be to go ahead and solve this as a system of two linear equations. So let's take this and let's go ahead here and simplify this one again. I think we had y equals 3x minus 13 originally here in our last problem, and we had y equals 2x minus 8. Well, this one should set up pretty easily. Let's go ahead and just use substitution. I'm going to take my 2x minus 8, and since that is equal to y, I'm going to substitute that in for the y in my other equation. So I should have 2x minus 8 should equal 3x minus 13. Go ahead now and let's solve it here. We subtract our 2x from each side. Add our 13 to each side here to keep it balanced. And we should end up with 5 should equal our value of x. So we know that when x is 5, we may have equivalent equations here. We still need to figure out what the y value is, though, to actually have our full answer. So let's just take our 5 and plug it back in. And remember, it doesn't matter which one you plug it into in a system of equations, but you can always check by using the other one. So y is going to equal, and I'm going to plug it in right here, 2 times 5 minus 8. 2 times 5 is 10. We're going to have 10 minus 8. So we get y equals 2. So we're saying here at the point 5, 2, that is a solution to this equation on the right. Let's plug our 0.52 back into our other equation to make sure that it works there. So we've got 2, and remember I'm plugging it back into the original equation just to be safe that I didn't make a mistake in my work. So 2 equals 3 times 5 minus 5 plus 2. Well, let's just simplify this using order of operations. There's no need to distribute if I can simplify the grouping symbols first. 5 minus 5 is 0, so I have 3 times 0 plus 2 should equal 2. And we know the product of 3 and 0 is 0, and 0 plus 2 will give us 2, so we have 2 equals 2. So that works. So we can then justify the fact that these two equations will be equivalent when x equals 5 and y equals 2. If you have questions, make sure you ask your teacher. Thanks for listening. I hope this helped.